For more than 60 years, we've been told metformin works mostly in the liver and gut, but brand new research from 2025 reveals something scientists never fully understood. Metformin also works inside your brain, switching off a protein that blocks normal glucose control. This discovery, finally, answers decades of confusion and changes how we understand type 2 diabetes forever. Let's break down what this means, in a way every diabetic can finally understand. As diabetics, we've questioned everything: our medications, our bodies, and the advice we were given. The debates around metformin only made things more confusing, but when this new research came out, many of us finally regained confidence. Because metformin wasn't failing us. It was quietly working where almost no one was looking, inside the brain. For decades, doctors believed metformin acted through three main pathways: 1. Reducing glucose production in the liver, 2. Improving gut hormone signals, 3. Increasing insulin sensitivity in muscles. And while this is true, it never fully explained why metformin works for some people, barely works for others, or suddenly stops working altogether. Something deeper was happening, and now we know exactly what that missing piece was. Scientists at Baylor College of Medicine have discovered a completely new mechanism. Metformin travels into the ventromedial hypothalamus, or VMH, the brain's metabolic command center. Inside this region, metformin switches off a protein called RAP1. RAP1 is like a block, preventing your brain from properly controlling blood sugar. When metformin turns RAP1 off, your metabolic system starts rebalancing itself. This is something we were never told, because no one knew, until now. We'll mute the audio for the next 40 seconds. Please watch the lab sequence closely. Researchers at their terminals are mapping VMH activity, and the callouts on screen show the real-time response. As you've witnessed, the researchers then traced metformin's effect to specific brain cells, SF1 neurons, the master regulators of hunger signals, stress-related glucose spikes, energy balance, fat-burning decisions, and insulin sensitivity. When metformin reached these cells, they activated instantly, and glucose control improved. This is the first time a diabetes medication has been mapped directly to individual neurons. To test the theory, scientists bred mice with RAP1 removed from their brains. Then they gave them metformin. The results were stunning. Metformin had zero effect on these mice, but other diabetes medications still work normally. This proves one thing clearly. Metformin depends on the brain pathway to work. Not the liver, not the gut, but the brain. After 60 years, the mystery is finally solved. This explains so much about the real-world experience of diabetics. Why stress causes sugar spikes even on metformin, why cravings hit during emotional days, why sleep disruption ruins glucose numbers, why some people respond quickly, and others barely see any changes. Because diabetes has always been more than a pancreas issue, it's a brain-body metabolic imbalance. We once questioned metformin's drawbacks: B12 depletion, gut side effects, inconsistent results. This new research doesn't erase those concerns, but it finally puts everything into context. Metformin wasn't a flawed drug, it was a misunderstood one, because it was working in the one place we weren't looking: the brain. To help you understand how this brain circuits truly shape diabetes, we created an educational deep dive called The Brain of a Diabetic, connecting the dots between body, brain, and truth. This guide is our way of organizing these complex ideas into a clear, accessible format. We've spent countless hours poring over dense scientific literature from journals like Nature Metabolism and the Journal of Neuroscience to distill the core principles for you. We believe that when you understand the why behind your body's signals, you're empowered in a completely new way. This isn't just about knowing facts, it's about building a mental model of your own biology, connecting the dots between what you feel and what science is discovering. It lays the foundation for why the brain controls insulin, cravings, stress spikes, and blood sugar itself. Inside, we unpack the concept of the brain-liver axis, explaining how signals from the hypothalamus can directly instruct your liver to produce more or less glucose, independent of what you've eaten. we also explore the neurobiology of cravings, tracing them back to reward pathways in the brain that can become dysregulated, and how that connects to blood sugar volatility. You'll learn how the brain's stress response, orchestrated by the HPA axis, releases hormones like cortisol that can directly cause insulin resistance and elevate blood sugar. Understanding this central control system is the key that unlocks so many of the frustrating, seemingly random symptoms associated with metabolic health challenges. It reframes the conversation from just managing peripheral symptoms to supporting the central command center. And if you want to go even deeper and see which natural supports our team found that work best with metformin's new brain pathway, we've put together a free presentation that explains everything step by step. This presentation is where we connect the dots from the foundational science to practical, evidence-informed strategies. We'll walk you through the specific research on how certain lifestyle factors and natural compounds can support the health of those critical SF1 neurons in the hypothalamus. For example, we'll discuss findings on how specific micronutrients are essential for neurotransmitter synthesis, the very chemical messengers your brain uses to regulate glucose. We'll touch on the role of anti-inflammatory compounds in cooling down the neuroinflammation that can disrupt hypothalamic signaling, a concept gaining significant traction in recent scientific reviews. We also dive into the mechanisms behind how improving sleep architecture, not just duration but the quality of your deep and REM sleep, can directly improve the brain's ability to manage glucose overnight. This isn't about miracle cures, it's about understanding the biological pathways and learning how to support them intelligently. We've synthesized data from dozens of studies, including randomized controlled trials and meta-analyses, to present a clear picture of what the current evidence suggests. We'll discuss how these supports don't work against your medication, but rather in concert with it, by nurturing the very brain pathway that we now know is so crucial for metformin's effectiveness. It's about creating a synergistic effect, where your lifestyle and your medication are both aligned with your body's fundamental biology. We've designed this presentation to be incredibly practical, translating complex neuroscience into actionable insights you can discuss with your healthcare provider. Our goal is to empower you with a deeper level of understanding, so you can be a more active, informed participant in your own health journey. We believe this knowledge is too important to keep locked away in scientific journals. You'll find the link in the description and the pinned comment below. Tap the free presentation link and continue learning while it's still available. Now, back to the findings. Even with this discovery, metformin's effectiveness still varies, and now we know why. The VMH and SF1 neurons are extremely sensitive to chronic stress, high cortisol, poor sleep, emotional overload, inflammation, nutrient deficiencies, neuron fatigue. If these brain circuits are overwhelmed, metformin struggles to do its job, but when the brain is supported, blood sugar becomes far easier to control. You don't need extreme diets or complicated programs. The science we've just explored reveals that the most powerful changes are often the most fundamental. By supporting the brain's own regulatory systems, we create an internal environment where treatments like metformin can achieve their full potential. It's about working with your body's biology, not against it. Here are 5 proven ways to support your brain metabolic circuit. First, improve deep sleep. This does more than just rest your body. It resets the brain's glucose control. During the deepest stages of non-REM sleep, your brain activates a kind of cleanup crew called the glymphatic system, which clears out metabolic waste that accumulates during the day. This process is vital for neuronal health, especially within the energy-sensitive hypothalamus. Research published in journals like has consistently shown that sleep deprivation disrupts the hypothalamic pituitary adrenal axis, our central stress response system. When this axis is overactive, it can contribute to the very same RAP1 signaling that metformin works to inhibit. A single night of poor sleep can temporarily reduce insulin sensitivity in the brain, making it harder for your hypothalamus to accurately sense and regulate blood sugar levels. Prioritizing consistent high-quality sleep is a foundational step in calming this entire circuit. Second, lower chronic stress. This directly reduces RAP1 activation. As the 2025 Baylor study revealed, the RAP1 pathway within our SF1 neurons is a key target for metformin. But this same pathway is also highly sensitive to stress hormones like cortisol. When we experience chronic stress, whether from work, personal life, or even poor sleep, our bodies are flooded with signals that tell the brain there's a persistent threat. This state of high alert keeps the RAP1 pathway switched on, effectively working against metformin's intended action. By incorporating stress management techniques like mindfulness, deep breathing, or simply spending time in nature, you can help lower circulating stress hormones. This sends a safety signal to the hypothalamus, allowing the RAP1 pathway to quiet down. This creates a more receptive state for metformin to perform its job, helping to restore the brain's natural ability to manage glucose. Third, eat anti-inflammatory foods. This supports neuron communication. The neurons in your hypothalamus are incredibly delicate and susceptible to inflammation, a process sometimes called neuroinflammation. This low-grade inflammation can impair their ability to sense and respond to metabolic signals like insulin and glucose. It's like static on a phone line, distorting the critical messages your brain needs to maintain balance. Foods rich in omega-3 fatty acids, such as salmon and walnuts, and antioxidants found in berries and leafy greens, provide the raw materials to combat this inflammation. These compounds can help protect the delicate membranes of your SF1 neurons and ensure their signaling pathways remain clear and efficient. A less inflamed hypothalamus is a more sensitive hypothalamus, better able to communicate with the rest of the body and regulate energy metabolism effectively. Fourth, reduce processed sugars. This directly prevents hypothalamic inflammation. While anti-inflammatory foods help calm the system, processed sugars and refined carbohydrates can actively promote inflammation. When consumed in excess, they can trigger an inflammatory response directly within the hypothalamus. Studies in journals have shown that high-sugar diets can induce a state of hypothalamic insulin resistance, a key feature of metabolic dysfunction. This inflammation makes the SF1 neurons less responsive, forcing the body to rely on less efficient peripheral mechanisms for glucose control. By reducing your intake of sugary drinks, processed snacks, and refined grains, you remove a major source of this neuronal stress. This gives the hypothalamus a chance to recover its sensitivity, complementing metformin's action and restoring a more robust, brain-centered approach to glucose regulation. And fifth, maintain healthy levels of B12 and magnesium. These micronutrients are critical for neuron energy metabolism. The SF1 neurons in the hypothalamus are some of the most energy-demanding cells in the body. They require a constant, powerful supply of energy to monitor your metabolic state and send out regulatory signals. Magnesium is a key player in producing this cellular energy, while vitamin B12 is essential for maintaining the health of the protective sheath around neurons, ensuring signals travel quickly and efficiently. It's well documented that long-term metformin use can be associated with lower B12 levels. Therefore, being mindful of these nutrients is especially important. Ensuring adequate levels through diet or, if recommended by your doctor, supplementation, provides your critical brain cells with the fuel and protection they need to function optimally. Always discuss any concerns about nutrient levels or supplementation with your healthcare provider. These small shifts make metformin and natural supports far more effective. They aren't separate from your treatment, they are an integral part of creating the biological conditions for success, turning your own brain into your most powerful ally in managing your health. This breakthrough marks the beginning of a brain-first era of diabetes care. Future treatments will focus on brain circuits, stress pathways, appetite signaling, neuronal inflammation, brain-body communication. Metformin was the first hint, now science is catching up. For many of us, this isn't just science, it's hope, because now our struggle makes sense. Diabetes isn't about willpower, it's not just about food. And it's not only a pancreas problem, it's a brain-body imbalance. And now we finally know where healing begins. We've journeyed together through a remarkable landscape of discovery, from the familiar actions of metformin in the liver and gut to the very frontier of neuroscience. We've seen how this medication, used for decades, holds secrets that science is only now beginning to unlock. The revelation that metformin's primary glucose-lowering power might originate deep within the brain, specifically by activating the RAP1 pathway in your hypothalamus's SF1 neurons, is more than just a scientific curiosity. It represents a fundamental shift in how we understand metabolic health. It reframes the conversation from a simple peripheral issue to a complex brain-body dialogue. This new understanding doesn't invalidate what we knew before. It enriches it, adding a crucial layer of control that explains so much of the variability we see in real-world results. It helps us appreciate why factors like stress, sleep quality, and even our daily rhythms can have such a profound impact on blood sugar management. They aren't just lifestyle factors, they are direct inputs into the very same hypothalamic control center that metformin targets. This is the paradigm shift we've been exploring, and it opens up a world of possibilities for more personalized and effective support. If you want to go deeper into this breakthrough, and see the natural supports our team found that best complement metformin's newly discovered brain pathway, watch the full discovery, our free presentation. This isn't about replacing your current plan but about enhancing it with precision. It's about understanding the why behind the frustrating plateaus and the unexpected successes. Why does a good night's sleep sometimes feel more effective than a dose adjustment? The answer lies in the hypothalamus. Why do stress reduction techniques help stabilize glucose levels? Because they directly soothe the SF1 neurons that metformin relies on. Our comprehensive presentation is designed to empower you with this knowledge. We've meticulously compiled the research, including the pivotal 2025 Baylor College of Medicine findings, and translated it into actionable insights. Inside, we break down the brain circuits in simple terms and reveal which natural metabolic supports work best alongside your current routine. We'll walk you through the science of neuroinflammation and how it can interfere with hypothalamic signaling, making your body less responsive. We'll connect the dots between circadian rhythm and the timing of metformin's effectiveness. You'll learn about specific nutritional compounds that have been studied for their ability to support neuronal health and reduce the cellular stress that can disrupt these delicate brain pathways. We'll also discuss the crucial role of B vitamin status, not as a side effect to be managed, but as a foundational element for optimal neurological function, which, as we now know, is central to metformin's action. This is the missing piece of the puzzle for so many, the link that connects lifestyle, medication, and the body's master control system. The journey to better health can often feel isolating, filled with confusing data and conflicting advice. Our goal with this presentation is to cut through that noise. We believe that understanding the how and why of your own body is the most powerful tool you can possess. This information is too important to be kept behind the paywalls of scientific journals. That's why we're committed to sharing it freely for as long as we can. This isn't a sales pitch, it's an invitation to become an expert on your own health, armed with the latest, most profound insights from the forefront of metabolic science. We want to thank you for spending this time with us, for your curiosity, and for your commitment to your well-being. The path forward is one of integration, where we honor the intricate connection between our brain and our body. Tap the link in the description and comments below before it's taken down. No hype, just clarity, science, and hope. Together, we level up.